For the fourth experiment entitled Impact Speed, this experiment aims to determine the speed of a falling object when it comes into contact with the ground using the laws of kinematics and equations of motions. The materials that are used in this experiment are ping pong ball, stopwatch, and tape measure. Using the formula h is equal to 1 over 2 gt squared, and with the measured value of height, the group members calculated for the theoretical time of the fall of the ball that represents the time it would take for the ball to reach the ground if there were no air resistance. Theoretical time is 0.64 seconds. After determining both the theoretical and actual time, the group members sketched a graph showing the ball's fall time and speed. The horizontal lines show the final speed of the fall, while the vertical lines represent the time of fall. The other two lines, which are diagonal and curved, show the speed at which the ball is dropping. Guide questions. For the first question, what can you say about objects whose speed versus time curves are close to the theoretical speed versus time line? To this question, the group answered that a small amount of air resistance prevents the object from falling as quickly as the theoretical time. For the second question, what does the area under your speed versus time graph represent? The group responded with the area of the graphs showing theoretical speed versus time and actual speed versus time, which depict the distance the ball had fallen. For the third question, the equations for distance traveled is d is equal to vt. In this lab, the distance fallen is the same with or without air friction. How do the average speeds and times compare with and without air friction? Try to use different size symbols as those used on page 66 of your text. To this, the group answered with d equal to vt. In an environment where we can disregard air friction, the average speed of a falling object and the time it takes to land to the ground is much faster, as the air friction tends to slow down an object, resulting in a lower average speed and time. For the fourth question, if you dropped a large leaf from the Empire State Building, what would its speed versus time graph look like? How might it differ from that of a baseball? According to the group, since it would take so much time before it touches the ground, the speed versus time graph would be horizontal. A large leaf and a baseball dropped from a height like the Empire State Building would show very different speed versus time graphs. With their final speed being the primary difference, the leaf would have a lower final speed than the more compact baseball because it is less dense and has a larger surface area. The baseball would therefore fall with a higher constant speed due to the air resistance. For the fifth question, the terminal speed of a falling object is the speed at which it stops accelerating. How could you tell whether an object had reached its terminal speed by glancing at an actual speed versus time graph? The group replied with, once the speed versus time graph illustrates a horizontal line, we can then conclude that this is the terminal speed of the object. This is because the horizontal line in a speed versus time graph indicates that the speed is not changing. Now for the conclusion. The group concluded that, given that the ball's reaction to air resistance was minimal, the actual speed versus time graph did not really differ from the theoretical speed versus time graph. The gravitational acceleration-based predictions and the observed motion correspond to each other. This experiment demonstrates a situation where the ball accelerates almost uniformly, and the effect of air resistance on its fall is minimal that makes the falling object, the ball, correspond to the theoretical physics predictions. Now for the conclusion. The group concluded that this experiment has given important knowledge on how air resistance affects the speed and time spent by a falling object. We have been able to precisely measure the effect of air resistance on a ping pong ball fall by putting them in controlled free fall situations. This information is necessary for comprehending the complicated connection between gravity and air resistance, highlighting the variables that affect the final speed and time it takes to fall for such objects.